All right, so here we go, continuing on with solving equations. If you remember from lesson 2.2, it was solving one-step equations, so I asked you to do problems 1 through 8 on the assignment. After this lesson, you're going to be able to complete numbers 9 through 12, which is the solving two-step. And then the majority of lesson 2.3 is the multi-step equations, which includes combining like terms, distributive property and combining like terms. So a lot of different multi-steps as it's called. If you recall, our main goal is to isolate the variable. So our goal is to solve for Q. If you wanted to check it again whenever you have figured out what you think Q is equal to, you would substitute that answer into your original equation, and you would use your order of operation skills to try and see if it's really correct or incorrect. So as we want to solve for Q, I need to go ahead and focus on inverse operations. So I'm going to look at that subtract 4 first, and I'm going to simply add 4 to both sides. If I add 4 to both sides, then I get a nice basic 22 on the right side. And then on the left side, again, the negative 4 plus 4 just gives us a simple 0. Now, you really don't have to write that if you don't want to, but some students do find it helpful. So now that I have 2q equals 22, I need to go ahead and continue with either multiplication or division. Now, if you remember, 2q is representing 2 multiplied by the value, whatever q is. So if that is the operation, then that means the inverse operation is to divide. We're going to divide both sides by a simple 2. If I do that, I'm going to get q is equal to 11. And if you wanted to, again, you would go ahead and substitute that at the Q location to try and check it. For this one tends to stump students quite often, no matter what level they're at, because if they notice it's a fraction line, but it's not a simple k over 3, it's a k plus 5 over 3. So it is considered a two-step equation on here. You have one very similar on the worksheet, which is lesson 2.3, number 3. So in order to continue to solve this, I still want to isolate k, but I got to get rid of that denominator first. It's a more advanced fraction, so I'm simply going to go ahead and multiply both sides by 3. Because on the left side, if I multiply by 3, that means the 3's would cross cancel. On the right side, negative 9 times 3 just gives me a negative 27. I can temporarily ignore those little ones, so therefore I no longer have a fraction to worry about. And for whatever reason, a lot of students have fears of fractions, but fractions, again, is one of those things that you'll be using throughout your life, whether it's through baking, cooking, measuring, anything like that. It's one of those skills that if you practice it more, the better you get at it. We're almost there. K plus 5 tells me I need to simply subtract 5 both sides. Now, notice on the right-hand side, this is where a lot of students struggle. They remember how to do the steps, but simple negative sign errors completely mess students' answers up. So on the right side, I've got a negative 27 and I have a negative 5. Remember, we are not multiplying these, so we're not going to use that triangle method to help us determine if it's a positive or negative answer. The rule states again that if both integers, when you're trying to combine them, are negative, then you're simply going to add them and it stays negative. So therefore, we have a negative 32. All right, so let's go ahead and focus on C, and then D is when you get to the distributive property. So let's see. On problem C, I've got a subtract 8, so it means I'm simply going to add 8 both sides. Looks like number 12 on lesson 2.2 is very similar to this one here. So you have a simple 3 over 2x is equal to 19. Now, just like what we did on the previous lesson, I'm going to go ahead and multiply both sides by the reciprocal. So on the left side, multiply by 2/3. Same thing on the right side. Remember, on the left side, everything would cross cancel. So 3's become 1's, 2's become 1's. So you have a simple x equals. On the right side, you check for cross canceling. 19 and 3 cannot cross cancel. So that means I need to go ahead and multiply my numerators, which would be a 19 and 2. And then I would simply say 1 times 3 for the denominators. So go ahead and multiply that out. If you can do it in your head, great. Remember, 19 is really close to 20. 20 times 2 is 40. So 19 times 2 is really close to 40. That's how we get our 38. And then again, our denominator is a simple 3. So in the lesson 2.2 worksheet, very similar to problem number 12. All right, next one. If you notice, we've got a number in the front of your parentheses. You've used your distributive property a lot in 7th grade, 8th grade, IM1, and so on. Being very careful with our signs, because again, that's one of the biggest mistakes that students make on these problems. So if I multiply -2 and x, it just gives me a -2x. But being careful here, remember, we read it really as -2 multiplied by -1. So if you were to take a pencil or a finger or whatever and cover up that x, the variable, you would hopefully be able to see it as -2 multiplied by -1, which is a +2. So a lot of students who make mistakes would actually say a subtract 2 instead of a +2 at that location. And then if you notice, we have it back to a nice two-step equation. So I'm going to go ahead and subtract 2 both sides. So it gives me a -2x is equal to an 8. We're almost there. Divide -2 on both sides. A +8 divided by a -2 is a -4. Now remember, if you accidentally put it as -2x subtract 2 equals 10, and you were to solve it, you would get a completely different answer. And if you were to go back to the beginning and substitute and check, you would not get a 10 equals 10. You'd get a different number. So that's when the checking can really come in handy. So again, as we stated, fear of fraction can cause some issues with students. So you really don't have a question like this on your worksheet, but just wanted to show you again that if we were to multiply everything by the LCD, which is a 6, because a 6 can stay a 6 and a 3 times 2 is a 6. So if we multiplied everything by a 6, it would actually come out to a much easier problem. So the first part, the 6's would cross cancel, so you just get a simple 5x. On the next part, the 6 and 3 cross cancel, so you really have a 2 times 2, which is a 4. And then on the last part again, the 6 and the 3's cross cancel, so you really have a 2 times 4, which is an 8. Going over this one again because you might have a question like this on your quiz the following day. But yeah, if you notice, you now have a much better problem to complete. So we just got to subtract 4 both sides. And then to finish it off, we divide by 5. So x is equal to 4 over 5. Let's see what letter F looks like. I think we can skip that one. Let's just see, going through it real quick, multiply by 45, which is the LCD. It's pretty much the same thing, just a little bit more complicated. Let's see. All right, so the last thing I want to show you is a quick refresher. Let me write it down, so I'd like you to write it down as well. Let me grab my pen tablet. One thing that you need to be careful of in lesson 2.3 and possibly even 2.4, again, is combining your like terms. So on several of the problems, it has, let's say, negative 3x plus a 5x. So of course, you have more than that, but wanted to remind you again that to combine like terms, they have to have the exact same variable. So a negative 3x and a positive 5x, you can use your rules, you can use your number line method. I like the rules again, which tells me different signs I subtract, which gives me a 2x. And it stays positive because the 5 has the greater absolute value. Sometimes I've asked students on a really complicated problem to actually box the like terms, and that can be very helpful. Let's say you have a different part. Instead of combining like terms with variables, let's say that we have a negative 9 and a positive 3, meaning no variables, but you still need to combine them. I ask my students again to essentially circle those. Notice I'm circling the signs as well. Different signs again tells me to subtract, which gives me a 6. And then the negative 9 has the greater absolute value, so that means I need to make it a negative 6. So specifically on question 5, and then eventually on question 6 and 7 of lesson 2.3, after you do your distributive property, you need to combine your like terms, which again is the box and the circle method like I just showed you there. All right, you're going to be awesome and do the best that you can.